and welcome to another level 3 5-minute video. We're going to talk about the physical properties of water in this short video. So what are the physical properties of water? We're really talking about the thermal capacity and the viscosity of water. So viscosity, what's the definition of viscosity? Viscosity is a material's internal resistance to flow. And thermal capacity, what do we mean by thermal capacity? It's how much heat it's holding, but the actual strict definition of thermal capacity is the energy required to change 1 kilo of substance by 1 degree C. So there's two definitions that we really need to know. If we're looking a bit more detail at the viscosity of water and how it can change, then I covered this a long time ago when we talked about size presses. But viscosity of water is affected by temperature. If we increase the temperature, then we reduce the viscosity of water. If we reduce the temperature, we increase the temperature of water. And although we can't see it as humans, because the viscosity of water is so low anyway, the paper can see this viscosity change because the pores of the paper are so small and it magnifies the effect of viscosity changes. Another thing that will change the viscosity of water is the concentration of materials that we dissolve in it. You take some water, it's nice and fluid, but if you start to dissolve sugar in it more and more and more, then it will become syrupy because the viscosity is increasing. So there's a nice simple example of how the concentration of materials will increase the viscosity of water, and that's a very easy one to see. So increasing concentration generally always increases viscosity. Then we've got molecular size. If you've got some really long molecules like these long bits of spaghetti here, if you try stirring this, then all this spaghetti will get entangled. Similarly, if you've got very long molecules, they will become entangled, and so you'll have a very viscous solution. If you have exactly the same concentration of spaghetti, but we've cut it all into very, very short particles, then when we stir those, because they're so short, they cannot become entangled, and therefore you would have a much lower viscosity. So long molecules will tangle, increasing viscosity. Short molecules cannot tangle, so you'll get a low viscosity. So the type of material that we use, or the molecular size of the material, will significantly affect the viscosity of the solution. And then just a quick mention of pH. Depending on what the molecule is, some particular polymer molecules have a certain shape, and by changing the pH you will change the shape of that molecule, and that in itself will affect the viscosity of the solution. Simple example of this, if you take some common fairly cheap shampoos, if you simply they have a certain viscosity. If you put some salt into that shampoo and give it a bit of a shake up, as the salt dissolves, it will change the ionic strength and the viscosity of the shampoo will increase. So, changing the shape of molecules can affect the viscosity. So that could be done with pH, it might also be done with ionic strength. The second property of water we need to talk about is the thermal capacity of the water. So this is how much heat it's holding. So many mills like to run the processes 45, 55 degrees C. I'm even seeing some up to 65 degrees C these days. The reason why we like to run at such high temperatures is the viscosity of the water is less, and therefore it drains quicker through the sheet on the forming fabric, and you can squeeze it out more easily in the press section. So higher process water temperatures reduces the viscosity of the water, aiding drainage. But it costs money to get the temperature that high. Negative side of it is that if you've got certain chemicals in there like AKD, things that deteriorate with time, its chemical reaction speeds increase with increasing temperature. So some materials will deteriorate more rapidly. So the paper maker has to get this balance then of how rapidly can he afford these materials to deteriorate against how much drainage improvement does he want to obtain. And of course, if you then introduce fresh water is going to be cold, so it's going to cost the mill money to heat it back up again to the normal process temperature. So we don't dump process water lightly, because it costs us to replace it with cold water that we then need to heat up. So a summary of the physical properties of water. Viscosity can be affected by temperature, concentration, the type of substance and the pH, even the ionic concentration. Replacing hot process water with cold fresh water is going to be expensive. And finally, hot process water is good for drainage, but materials like AKD will deteriorate faster. Okay, well, thank you for listening to this short video, and please feel free to follow us on any of this social media.